Welcome to Moss Landing. That is the famous boat, the Western Flyer, in the background. And here we are at the Sunflower Star Laboratory with Mariana Jimenez, who is our guide today.
Well, let's check out the stars. We've got our largest star Titan in the corner over here, and then we've got some other siblings in this tank below.
So Titan in the back corner.
Titan in the back corner. They're probably working on an urchin right now. Siblings. There's 6 in here, and in the back you can see all the urchins that these stars have eaten. You can see their skeletal structure, the tests of the urchins and the spines as well. And there's some stars in this patch of algae right now that are currently working on eating some urchins that we fed them earlier. This is the life cycle of a sunflower sea star, and so this is when they start to spawn or produce their gametes, and so fertilization and their growth happen in the water column. So that's what this blue is representing, is them in the plankton floating around, swimming, and then the transition into the brown is when they metamorphose into a sea star. And so they are really tiny and they're starting to eat and grow. And so all of our stars are currently juveniles. They're only almost 2 years old. And when they reach adulthood, they can be up to a meter long in diameter. And so we really enjoyed this life cycle to share with people to explain what their life history is like. In this table, we've got a bunch of other little stars. So in total here at our lab we have about 96 sea stars, and so these guys are the same age as Titan like you saw earlier, but these guys were settled way later. So they were in their larval form for months longer than Titan was, and so they're a little behind on growth, but they were still born on the same day. Well, bubbling away in this table right here, we have our once frozen larvae of not the sunflower sea star, but a similar species, just giant pink sea stars. And so this is our 3rd run of the experiment, but these guys were once frozen, but now they've been completely rehydrated and are floating around eating and are going to be settling and becoming sea stars pretty soon in the next couple weeks.
And how long were they frozen?
They were frozen since January of this year, so it's been almost 12 months that they've been frozen. And so we've done 3 trials of this now, and each one has been successful, and we've learned a lot of really amazing, important things from those experiments. This is our microalgae room. So when they're floating around in that larval form, they're needing to eat a lot of tiny foods. And so bubbling away here is our microalgae. So they're just tiny enough for the larvae to eat. And the different colors of red basically are like how dense a population is. And so we harvest the feed, meaning the microalgae, when they're about this dark red color. And so it's about once a week that they get harvested. And so this room is super important for when we have a bunch of larvae, because again, they need small food to eat.
And the red is their natural color, not green?
It is. So it depends on the type of microalgae. So what we currently have is Rhodomonas salina, and it's a type of single-celled red algae, and so that's why it gives off this red hue.
Oh, cool.
Yeah.
Let's see if I can get a close-up view.